Hi Roboticist! In the last video I showed you how to display an image using the point cloud 2 topics, but I think that if we are gonna go further in this perception, you won't understand so much, because it's the perception word is a little bit complicated, and so I decided to make a step back and run this series in perception, and in particular perception in robotics. We are gonna have a look on the algorithms that are available out there. We are gonna use OpenCV, and most likely after some video that you have learned with the basics, you will understand better the point cloud 2. So we are gonna have a better perception of the world that surrounds the robots in order to make a proper pick and place application, or better understand where the object that has to be picked is in the environment. So before to start, make sure to subscribe to this channel, hit the notification bell, and if you want to have a deep dive into ROS, let's have a look on the courses for a beginner. And now let's get started. Okay, first of all, what is perception? A perception is a way to sense the environment, and most of the time, if you don't have any sensor or any camera, well, your robots can be considered only as a manipulator, because it doesn't sense the environment. Is you with programming that needs to set up the position of the object that you want to pick and where to place, using inverse kinematics algorithm. But it's not a robot. A robot is a mechatronic system that first senses the environment and makes up actions according to that. So if we want to deal with perception, what we're gonna do is to use a computer vision libraries, and the most common one is OpenCV, which stands for Open Computer Vision Libraries. This has been developed from Google, and it is open, so you can download in your workspace into your workspace and start to work with that right away. So it's a powerful tool to sense the environment. It has a lot of libraries like object detection, face recognition, and a lot of things that we're gonna see in a while. So the first thing that you need to know is to know how the image is, how an image in general is seen from this algorithm, and afterwards you have to imagine that a video is just a collection of images, if you think a collection of frame. So first things that you need to know is to understand how an image is built. So if you have an image, you can consider an image like a matrix built of these three channels. channel. So it's a three-dimensional matrix where here you have the length of your image and the width of your image, and this is a representation of RGB image, so red, green, and blue channel, and each pixel is you can consider as a point in your matrix that has some values that goes from 0 to 255, and in red from 0 to 255 in green, and from 0 265 55 in blue. So if you're gonna see a spot in your image that is green, that pixel will be composed in that point will be 0 in red, 255 in green, and 0 in blue. So basically this is a first things to know on how an image is recognized with the computer vision libraries. Since that we want to interface our world, our gazebo world, and our ROS environment with these libraries, what you need to know is to know how ROS recognize an image. So in ROS, an image has been described thanks to this message, sensor messages image. And it's going to be a complex message. It has an header, it has a height and width, it has an encoding of pixel, and then has a lot of data. And basically the most important one is this one. So it's a matrix that has all the information like we have in this image. So basically the point here is that if we have a camera that publish an image of our environment, and we want to use the OpenCV libraries, we need to make some kind of conversion between these two ways of describing the image. Okay, luckily there's a ROS package that is called CvBridge, that stands for a computer vision bridge, that makes this connection between how ROS sees an image and how OpenCV see the image. So this is very important, and we're gonna use this one. Okay, so after this introduction, let's create another package to start to work with OpenCV, and later to interface the ROS environment and gazebo to play with OpenCV. So let's get started. So first of all, open a new terminal and create in our source folder of our cutting workspace a new package, and we call it OpenCV tutorial with ROS Pi dependencies. Okay, here we are in our package, and let's make some structure. So we are gonna have a launch folder, then we are gonna have an images folder, where inside this image folder we are gonna have some another folder that we are gonna put some images, and we are gonna read from those. And always here we are gonna have another folder that we can call it put. So basically, if we are going to make some modification and save some photos, we are gonna put it here. Okay, so here we go. What we can do is to put an image here, and the first things that we want to do is to load that image to actually displays on the screen. So I have put this image that I have downloaded from the web, and basically this is a normal image, very easy, a PNG file. So let's make a file and call it load image. Let's make an executable file. Okay, here we go. First things first, we need to put the interpreter. Load the library. So this is the library of OpenCV, so import CvBridge. So this is a file that it will not be a node. It's just a simple Python code that has nothing to do with ROS. Just to warm up a little bit and try to make some confidence with computer vision. So let's create a main here. So here we need to give the path where we can find this image here. So we can call it image, and then put the pathway here. And then if you wanna give more structure to this script, let's create a class and work with the method, because it's more structure. So let's instantiate an object that we call load image object. And then we are gonna call the class that we are about to create in a while, and we're gonna pass image. Okay, so now let's create this class. Okay, since that we need to pass an image, let's create the constructor here. That will be the picture that we want to load. And then let's create a method just to read the image. To load the image, we are gonna use the imRead method. And we're gonna load the picture, so self.picture. And then if you want to display on the screen, you're going to use the method imShow. We are going to call it image, and we need to pass the image that we want to display. It's going to be img. and then we can keep it displayed on the terminal using the wait key function. So after that, what we need to do in the main is to call that method read a photo. So the object that we have created, and we call the method read photo. Okay, here we are. This is the most simple code that you can have using OpenCV. I remember is nothing to deal with ROS. It's just a Python code in Visual Studio Code. So for that reason, we don't need to run the ROS master. We can just play it and run this Python file. Let's test it and see what happened. Okay, here we go. We have the image, the PNG picture displayed on the screen. So basically, here we go. And what is really interesting here is that you can see from here, this is x, the location, the coordinate x and y. So we can see that on the top left side is gonna be 0 0, and then if we go down, the x is gonna be 0, and the y is increasing, and if you go left, if you go right, then the x increases. So it seems that the origin is this one, and this is the x, this is the y positive direction, and this is x the positive direction. And here, for example, this is yellow, so we can see that we have this pixel where I'm pointing the mouse. The red is gonna have the color 252, the green 224, and blue 101. If we go here, this is a red, and you can see that the red channel is much higher than the green and blue, and if this is gonna be green, then we have the opposite. So the green it's much more higher. Okay, so now let's rise a bar a little bit, and let's integrate an OpenCV libraries in ROS. So what we are gonna do now is to ask Gazebo to subscribe to a topic sensor message, and then we are gonna create a new file that will subscribe to that topic, and we are gonna read that image, and we are gonna save the image in the output folder. Okay, it's not complicated, but let's do it together step by step. Okay, so let's modify this this file, and to do that, let's create another one, and we can call it load image from camera.py. Okay, so here what we need to do, we can modify this as a reference. So let's modify this file in order to display the image that the camera of our environment that we have created in the last video actually sees. So first of all, let's make load image from camera.file and executable file. Okay, so first of all, what we need to import is the CvBridge that, I repeat, is necessary to make a bridge and make the conversion between the sensor message structure to the image that OpenCV can actually process. Then the second thing that we need to import is the sensor message, because this is the structure of how ROS, or better the camera, sees an image that, as we can see, it has this kind of structure here. Okay, so these are the library that we need. So first of all, let's modify the main file. So this, for the moment, we don't need. This we don't need in order to be generalized. We're gonna see in a while. So here we are gonna have a normal object, a general one, and now since that is gonna be a node file, we need to initialize the node. So I remember you that with the ROSPy library we need to type ROSPy and then init node, and let's give it a name. Since that we are gonna display the image from the callback function that will be embedded, let's say, in the subscriber, let's avoid to have these methods. And what we can do is to spin the ROSPy to keep it alive. So what we can do is to type try and then ROSPy dot spin. We're going to use the spin function, and if we are going to interrupt, we can say that except we are going to type a keyboard interrupt, and then we can say that if we're going to type something, we can print on the terminal shutting down, and then cv2 dot destroy all windows. Okay, so here we have started to initialize the ROS environment somehow. Okay, so what we need to do now is to adapt the constructor here. And first of all, what we're gonna do is to create a subscriber that will subscribe to the topic that contains the data of the image that we wanna display, and the gazebo, or better the camera that is in gazebo, will publish. So let's self, so we are gonna create this subject, so we need to image subscriber. Then this is a subscriber that in Python, I remember you that is gonna be ROS.py, then subscriber, then you need to put the name of the topic and how to check this. Well, first of all, let's run in another terminal our simulation environment in order to check what is the topic that we want to subscribe to. Okay, so let's run our simulation environment in order to check what will be the topic that we're going to subscribe to. Let's run in another terminal ROS topic list. Okay, if we wanna see what our camera sees in our environment, it will be this one, or better, for the way that the camera has been coded. We are gonna see only the last part of the table and this object here. So let's see what will be how we named the topic. That should be RGBD camera, then RGB. Here you are, image row. So this is a topic that, for the way that is constructed, is of type image that we have seen so far, and this is RGBD camera, RGB image row. So let's copy this one and paste in our code, or better, in our subscriber. Here we are. So this topic is of type image that has a structure sensor messages message, and then I remember you that if you deal with the subscriber, you need to have a callback function. So we're gonna call it camera callback, where we are gonna process the data that are coming from this topic, and we're gonna do something. And in particular, what we're gonna do is to display the image on the screen and save the image in the output folder. Okay, let's do it. So first of all, let's comment this out, but just keep it for reference, just to remember as how to show an image. So what we're gonna do now is to first of all update the name of the method. That is gonna be camera callback. And then we are gonna try to convert the image here to an image that computer that CV2, that OpenCV can process. So to do that, let's create a variable and let's call CV image. Then we are gonna use bridge of object. That's this something. Sorry for that. We need to construct here in the constructor. So self dot bridge object. We are going to instantiate an object CvBridge. Okay, so we can use this, and then we're gonna use as a method image message to CV2. Here you are. So this method is responsible to convert an image type of data that is subscriber to this topic to an image that OpenCV and the library CV2 can process. And we are gonna pass data and desired encoding. We need to pass it BGR8. So we select BGR8 because it's the OpenCV encoding by default. So the data is belonging to that. This callback function takes as an input the data that is coming from this topic that is of type image. That this image has the structure of sensor message. Sorry if I repeat this thing so much, but it's better to have more. It's better to repeat this in order to try to make this concept very clear in your mind. I hope that you appreciate that. This is if we're gonna have an exception. We're gonna print which kind of error we're gonna have. Okay, then what we need to do is to save this image to the output folder. And in order to do that, let's create a variable called path, which is gonna be just a string. That is gonna be this one. Okay, and if we wanna write and save an image into this folder, what we need to do is to call the imWrite method of CV2. So let's create a variable that is equal to CV2 dot imWrite, and then we're gonna pass a string that is path. Then we make a concatenation, and we are gonna call it a camera image dot png. And what is the image that we are gonna put in this folder? This one, CV image. And then what we can do is to display the image that we're gonna see on the screen. And to do that, we could actually show that image here. This is the frame from camera, and then we need to display the CV image. We don't read this time we don't need to read any image. So here we go. So here we go. We are gonna have this main where we are gonna call the class load image, and then in this load image we are gonna create in the constructor the subscriber object that is going to subscribe to this topic RGBD camera RGB image row that is published from the node gazebo, and this topic has a structure image, and in order to see that image, we are gonna process into the method camera callback, and here what we're gonna do is to convert the image from type sensor messages to a type that OpenCV actually can see. And since that now this variable contains an image that OpenCV can process, then we just do some things, and for this example we just need to save the image that we are gonna get from the camera into this folder, and we are gonna show this image on the screen. Okay, before to run it, we can create a very simple launch file. Okay, here we are. We just run this this node that we're gonna call load image from camera, that is taken from the Python script that we have just created. Okay, let's build the package and test it. Okay, so I remember that the camera is here, is a little bit inclined, and this is the direction of actually it can see, and the perspective will be something like this. So this is what this camera should see. It should see the last part of the table and the object, something that we can see also from the RV's environment, because we have used a point cloud to libraries. The launch file as right. We don't need any more. Now should work. Let's see. Here we go. This is what the camera see, the RGBD camera actually see, and you can see that this image is made in a format that OpenCV can actually see. You can see the coordinate in X and Y, the RGB value, and we can go also into output folder, and we can see that this image is correctly saved in this folder. Before to let you leave, let's see what is happening from the RQT graph, and see what is the publisher subscriber architecture. Okay, okay, here we go. You can see that okay, is getting more complicated. Our application, but something that you need to know is this one, is that Gazebo, this node here, is publishing a message of type sensor message on the topic RGBD camera RGB image row. And then what we have done today is that we have created this node that simply read that image and displays on the terminal, which is going to be this one. And we have used the CvBridge libraries to convert the sensor message data into an image that OpenCV can process. Okay, that's all for today. Thank you to stay with me till the end of this video. If you like this video, and if you want to share your thoughts about this video and this kind of series in perception, make sure to subscribe to the channel, hit the notification bell, and I hope that you can try this by your own. And as always, keep learning robotics with ROS.